So we're going to finish off today's lesson with example 12, which says determine the remainder when 27x cubed plus 10 is divided by 2 plus 3x. So we are going to use the long division algorithm. So 27x cubed plus 10 will be our dividend that goes inside the division symbol, while the 2 plus 3x is the divisor, which goes outside the division symbol. So let's draw in our long division. So inside we have 27x cubed plus 10. Now take note that when we're writing both the dividend and divisor, we want to write it in descending order in powers. So right now we have 27x cubed. Do we have any x squares? No, we don't have any x squares, nor do we have any x's. But we do want to prepare them in terms of a placements, in terms of the gap, so it looks pretty. So we're going to add in, so 27x cubed plus 0 x squared, because there's no x squared, and we've got no x's, but we do have a plus 10 in our dividend. So in descending order of power, so cubed, then squared, then x, then no x, make sure you have them as placeholders. Now for the divisor on the outside, 2 plus 3x, make sure that's also written in descending order of power as well. So 3x comes first, and then our plus 2 comes afterwards. Now we just need to divide. So first look at the highest power for both your dividend and your divisor. In this case it's 27x cubed and 3x. So you're thinking 3x times what gives me 27x cubed? Well, 3 times 9 gives me 27, so it's 9 something. X times x squared gives me x cubed, so I need a 9x squared. And you see how because of the placeholder, I align the x squared with the x squared placeholder. Right, so following like last time, using long division, I need to multiply this quotient with every term of our divisor. So 9x squared times 3x gives us 27x cubed. 9x squared plus times 2 gives me positive 18x squared. Make sure you put brackets around your subtraction, and we're going to subtract to find our remainder. So 27x cubed minus 27x cubed, it cancels for good reason. 0x squared minus 18x squared gives me a negative 18x squared. I carry down the remaining placeholders, so 0x and plus 10. So do the same thing again, look at the highest power of our temporary remainder, which is negative 18x squared, and you think, well, 3x times what gives me negative 18x squared? Well, 3 times negative 6 gives me negative 18, and I'm missing an x to get me x squared. So now you multiply through this quotient, negative 6x with every term in the divisor. So negative 6x times 3x gives you negative 18x squared. Negative 6x times 2 gives you negative 12x. Again, make sure you put brackets around it when you're subtracting to find the remainder. So subtract negative 18x squared plus, because negative makes a positive, negative 18 plus 18 gives you 0. That's good because you wanted to get rid of the x squared. 0 minus 12 gives you a positive 12x. We've still got a plus 10, so let's carry that down. So one more. 3x times what gives me 12x, because 12x is the highest power of my temporary remainder. 3 times 4 is a 12, so plus 4. Again, see how I've aligned the placeholders for your powers of x. So we need to multiply through the 4 with every term inside your divisor. So 4 times 3 is 12x, 4 times 2 is plus 8. Again, we need to subtract but put brackets around it because you're taking away the whole thing. So 12x minus 12x is 0, 10 minus 8 is a 2. So this tells us, next column, oops, that therefore the remainder when we divide 27x cubed plus 10 by 2 plus 3x, the remainder is 2, because when I subtract, it's 2 remaining. And you know you stop dividing, you know it's a remainder when this 2 has no x's, whereas in my divisor, the highest power is a single x. So you can't divide anymore because this 3x plus 2 has a higher x power than just a single number of 2. That's when you know to stop dividing through. So therefore, the remainder is